Hey y'all, this is Miss Hill, and in this video we're going to start off by talking about assumptions. So when you're given a diagram, there are some things you can assume. You can assume that lines are straight. You can assume that if two lines actually intersect, they intersect at one point. And you can also assume that if you see points on a line, they are collinear, and that all points are coplanar unless we draw separate planes to show that they are not coplanar. Now there are a lot more things that you cannot assume than you can assume. First, that lines that look parallel are not parallel. So you cannot assume they are parallel just because they look like it. They have to be marked as parallel. So lines that look perpendicular are perpendicular. That's not true either. They have to be marked with the right angle. And then any angles, segments, or polygons that may look congruent doesn't mean they are. Okay? They have to be marked with enough information so that you can tell that they are congruent. So now let's talk about some special named polygons, beginning with the triangles. Now this is going to be mostly review for everybody. So starting with the right triangle, it is a triangle with exactly one right angle, and they will be drawn like this with a little right angle drawn into the corner where the right angle exists. It may or may not have the other two angles drawn in there. An acute triangle is a triangle with three acute angles, and they need to be marked as acute in order for you to know that it is acute. An obtuse triangle is a triangle with exactly one obtuse angle. You can't have more than one, and it has to be marked as obtuse. Those are the three angles, or three triangles by angles. And then of course we have triangle names by sides. So we have a scalene triangle, which is a triangle that has no congruent sides, and you'll either be told it's scalene or the side lengths will be marked as distinct. An equilateral triangle is a triangle with all three sides being congruent, and you'll either be told it's equilateral or they'll be marked as equilateral, either by the congruence markings or the measurements will actually be included. And then isosceles triangles. This is a triangle with at least two congruent sides, and so they'll either be marked like this with the congruence markings, marked with the equal measures, or you'll be told they're isosceles and which sides are congruent. Now you may have noticed I put a little star next to the word isosceles triangle, and that's because this definition is a little bit different than what you're probably used to. It says at least two congruent sides, which yes, that means an equilateral triangle will qualify as isosceles because it has the same properties as an isosceles triangle, but equilateral is a much more specific term, and this is one of those squares, rectangles, rectangle, squares situation where an equilateral triangle is isosceles, but an isosceles triangle is not necessarily equilateral. So now it's time to talk about the quadrilaterals, the ones that we have special names for. And we're going to start with the trapezoid. So a trapezoid is a quadrilateral with exactly one pair of parallel sides, and this is the minimum level of marking required to designate a quadrilateral trapezoid. See, I have the one set of parallel sides. Now, of course, we have different types of trapezoids. We have the isosceles trapezoid, which is a trapezoid with congruent sides, but the non-parallel sides are congruent. So I have parallel sides, and then the non-parallel sides are marked as congruent. This is a picture of an isosceles trapezoid. Now, it's nice with these drawings, and I made them look like trapezoids, but I could have easily been super lazy and used my square template and marked one set of sides parallel and the other set of sides congruent. Doesn't mean it's a square because it looks like a square. It means it's an isosceles trapezoid because of the markings. Now remember, don't go by the way something is drawn, go by the markings. And the final kind of trapezoid is the right trapezoid, and that is a trapezoid with a right angle. So I see the set of parallel sides and I see the right angle marking. Therefore, this is a right trapezoid. Now we have two quadrilaterals that might be a little bit newer to some of you, at least the formal definition. We have a quadrilateral with two distinct pairs of consecutive congruent sides. Not opposite of each other like a rectangular parallelogram, but consecutive, meaning right next to each other. So I see these two sides are consecutive and congruent, and these two sides are consecutive and congruent. And we use the word kite for the convex quadrilaterals that have this property. And then if I want to talk about a concave quadrilateral with this property, we call it a dart. So you see consecutive sides congruent, consecutive sides congruent, dart, not a kite. Now we come to the quadrilaterals you should be most familiar with, starting with the parallelogram, which is a quadrilateral with two pairs of parallel sides. So you see I used my templates to draw the parallelogram shape, and I have one set of parallel sides, second set of parallel sides. Now this is the minimum requirement for something to be a parallelogram. It says nothing about the properties relating the sides or the angles, just the definition of a parallelogram. So now let's use some vocabulary to shorten the definition of things. So a rhombus is an equilateral parallelogram. Equilateral, remember, means all sides equal length. So I have the parallelogram with the two sets of parallel sides, and then the tick mark showing that all sides are equal of length. Then of course we have the rectangle, of which you should be most familiar, and it is an equiangular parallelogram, also known as a parallelogram with four right angles, because that's the minimum definition of it. I have sets of parallel sides, four congruent angles. In this case I drew them as right angles. I could have easily have drawn them with a little arc and a tick mark like this. I could also write them like this. Now finally we come to the square, which has multiple definitions. Okay? The square can be thought of as a regular quadrilateral, remembering that regular means all sides and all angles are congruent. An equiangular rhombus, all angles equal, rhombus gives us all sides equal. An equilateral rectangle, all sides equal, rectangle gives us the 90-degree angles. So these are three alternative definitions of a square. Now, of course, we know tons of properties like area formulas, the way their sides relate, the way their angles relate, but the point of geometry is to be able to prove that all of those properties are true and show where they come from. So that's what we're going to focus in on when we get into the meat and potatoes of geometry.